Hello everyone, welcome to lesson 13. Previously we finished chapter 1. All the ideas, all the techniques, all the rules have been explained in the previous lessons. Today we start chapter 2. Chapter 2 is about limits. Lesson 2.1 means the first section in chapter 2 is not in, so we directly begin with section 2.2. Section 2.2 is about limits, calculating limits. In general, limits means finding values of functions approximately, or finding the behavior of the functions as the x approaches to some certain numbers. If we explain limit on this graph, limit x approaches c means x getting close to the value c. This c is on x-axis. So if we say c is here, then this graph is the function fx. As we get closer to c, the value of the function gets closer to L. This means the limit x approaching c is equal to L, means as x approaches c, the value of the function gets closer to L. Then L is the result of the limit. Here we have an example of this approaching. Fx is equal to x cubed minus 1 over x minus 1. Find the limit as x approaches 1. X approaches 1 means x getting close to 1, means x is not 1 directly. We can get closer to 1 on both sides, left and right. If on the left side of 1, we get closer to 1, we have these numbers, 0.75, 0.9, 0.99. We get too close to 1. And on the other side, if we get closer to 1 on the right side, means approaching 1 on the right side, means getting closer to these numbers like 1.1, 1.01, 1.001. As we get too close to 1, by substituting these values here in the function, we record the results, then we notice something here in these numbers. These numbers get closer to 3 each time we get closer to 1. Here, these results, it's more than 3, getting smaller, getting closer to 3 as we get closer to 1. If we put 1 directly in the function, it will make a trouble for the function. It will be 0 over 0. Then when the result is 0 over 0, if we put 1, so f of 1 is equal to 1 minus 1 over 1 minus 1. 1 cubed is 1, minus 1 is 0, 1 minus 1 is 0. This case is not clear. We don't know if the limit exists or no. Then what we do left and right. The left limit is getting too close to 3. The right limit is getting too close to 3 as well. This means the limit is equal to 3. It's fine. F of 1 does not exist. It's 0 over 0. But the limit, as we get closer to 1, the result will get closer to 3. This means the limit is equal to 3. If we look at this on the graph, this is the graph of x cubed minus 1 over x minus 1. As we get closer to 1 on both sides, the graph, the result gets closer to 3. It's fine at 1, there is no graph. This open point means no graph at 1. No graph means no value. But since the graph looks like one piece, looks like one graph, the limit exists, and the result is 3. So this is the meaning of limit. The first point about limit, if after we directly substitute this value in the function, if we got something like 0 over 0, then we need to do left and right. If left and right are both approaching the same value, this means the limit overall is equal to this value that they get close to. Finding limits on graph. Okay. Then the question says find limits of x approaching a. This little negative here means on the left side. The question asks for the limit on the left side only. Then how we do it? We have a on the graph. Getting closer to a on the left side will make the graph get closer to this point. Result of this point is L. This means the limit on the left side is equal to L. On the right side, if I get closer to A on the right side, then on the right side means this little positive means on the right side. Then if we look at the graph, as I get closer to A, the result gets closer to this point, which is in front of L. Then since the limit of left side is equal to the limit of the right side, then the final answer is the limit exists and it's equal to L. So after I show the left limit and the right limit are both equal, then I can say limit x approaching A for fx without indicating left or right, because I did both, they are both equal. Then the limit at the end is equal to L and the limit exists. There are some cases on graph that the limit does not exist. Remember that every time when the graph looks like one piece, looks like one graph, the limit exists, even if this point is like open. If the point is like this, if the point is open, it's fine, the limit still exists because the graph is one piece and the piece is like one curve, it's completing each other. But when the graph becomes two pieces like this, whenever you see a graph that is two pieces, at this point, which the two pieces meet, here, the limit does not exist. On this graph, limit x approaching A does not exist because at A, the graph is two pieces and the result of the right side, the right limit, the result is 3. So limit x approaching A on the right side is equal to 3, while limit x approaching A on the left side is equal to 2. Since the left limit is not equal to the right limit, this means limit x approaching A does not exist for fx. Limit x approaching A for fx does not exist. Reason? Because the graph is two pieces at A. One piece goes to 3, one piece goes to 2. Left limit, right limit are not equal. Then overall, the limit does not exist. Similarly, we have these examples that limit does not exist. Here, limit of this function at 1 does not exist. Because if I approach this function, here, limit x approaching 1 for this fx, the graph is broken at 1. It's two pieces. Now I need to do left and right. Then since the graph is two pieces, I can directly say the limit does not exist. And the reason it does not exist, if I approach 1 on the right side, result is this graph, result is 1. If I approach 1 on the left side, is this graph, result is 2. Then 1 is not equal to 2, left limit is not equal to right limit, means limit does not exist. Similarly, here since the graph at 3 is broken, the limit at 3 does not exist. But the limit at any other number exists, had no problem. Like here, for this graph, if I say limit x approaching 3, this one does not exist. For fx, does not exist. But for the same graph, if I say limit x approaching 0 for fx, this one exists. At 0, the graph is not two pieces, it's one graph. At 0, result is 1, so the limit is 1 for 0 in this graph. The only problem in this graph is at 3. The problem in this graph is at 1. At 1, the limit does not exist. Here, at 2, the limit does not exist because on the right side, it's approaching positive infinity. On the left side, it's approaching 1. Then positive infinity and 1 are not equal, limit does not exist. So every time if you see the graph is broken, like this, limit does not exist. Here is a question. calculate the value of the function. Value of function fx is x over square root x plus 4 minus 2 when x takes several values near 0. Use your results to estimate the limit. Okay. Now, as x approaches 0, let's choose a number that's close to 0. A number close to 0, we can say on the left side, limit x approaching 0 on the left side. This one is about 0. If 0, we consider 0 here in the middle. A number on the left side of 0, we can say negative 0.1. That's a very small number and is too close to 0. On the other side, on the right side of 0, we can say 0.1. 0.1 is a very small number that is too close to 0. Now I'm going to substitute 0.1 here. See the result. Substitute negative 0.1 here. See the result as well. Then we can decide what does the answer equal to. Here, if we approach limit x approaching 0 at the left side, I'm going to substitute negative 0.1 here. This will be negative 0.1 over square root negative 0.1 plus 4 minus 2. Now using calculator to do this calculation, the answer will be 3.9, but let's do it. Negative 0.1 divide negative 0.1, calculating this side, square root, negative 0.1 plus 4 is 3.9, 3.9 under square root is 1.97, 1.97 minus 2 is negative 0.025. Now doing this division, negative 0.1 divide by negative 0.025. The result is 4. All right. Now, if we put 0.1 in place of x, that was the left limit. If we put 0.1 in place of x, we're going to do the same calculation with 0.1, and the result will be 4.02, which is too close to 4. Then we can say the limit x approaching 0 for this function is nearly equal to 4. The question says estimate. Estimate means nearly, so the answer is 4. This is a fast way that always works. When you want to do the right limit, we use a number too close on the right, like on the right side of 0, I choose 0.1. On the left side of 0, I choose negative 0.1. Then put them in the function, we get the result. The reason why I don't put the 0 directly, because the 0 itself is causing trouble for the function. Like if I write 0 in place of x, radical 0 plus 4 minus 2. Numerator is already 0. Denominator 0 plus 4 is square root 4 minus 2. Square root 4 is 2. So this will be 0, 2 minus 2, that's 0 over 0. 0 over 0 means f of 0 does not exist, but the limit exists and is equal to 4. For piecewise functions, how can we find limit? There is a note about it. Piecewise functions have two types. Some of them have these boundaries with inequalities. Some of them have it with equal, not equal. Now the note is about equal, not equal. Every time you see a function that is piecewise and it has equal, not equal, to do the limit, we always go with the not equal. Limit x approaching 2, limit x approaching 2 for this fx is, since we want to get close to 2, we don't want to get 2 directly, then we don't go with this one, only the upper one. So the result is 1. Then this limit exists and it has no problem and it's equal to 1. Remember that when we have the piecewise function as equal, not equal, we need to go with the not equal all the time. Another piecewise function. Let's do this. Find the limit of the function f as x tends to 0. Let's write what we have. Limit x approaching 0, all right, for this f, for this function. Okay. When x gets closer to 0, it means we ignore the part that has equal to 0. We ignore this part. We don't want 0. For limits, we don't want the 0. We don't want this number directly. What we want other numbers that get closer to it. Then we go with the left and right because there are two options where we can get close to 0. We can get closer to 0 on the left side or the right side. Now let's do it. Limit x approaching to 0 on the left side. Limit x approaching to 0 on the left side is this function, x minus 1, equal to. Now if we put the 0 directly in place of x, we will not get 0 over 0. Then this way is okay. Put 0 in place of x, 0 minus 1, negative 1. This is the left limit. Now the right limit, limit x approaching 0 on the right side. Right side of 0 are these numbers that are more than 0. Then we go with this, negative x minus 1. Again, if I put 0 in place of x, it will not be 0 over 0. Then it's okay. This will be, put 0 in place of x, this will be 0 minus 1, which is negative 1. Now look at the right limit and the left limit. They are equal. Since the right limit and the left limit are equal, then we say this limit exists and it's equal to negative 1. This question shows that the limit x approaching 0 does not exist. Let's do this. Now if I directly put 0 in place of x, this will be absolute value of 0 over 0. That is 0 over 0, then I don't know. F of 0 does not exist. But let's check left and right. Now look at this. If I write limit x approaching 0 on the left side for absolute value x over x. On the left side of 0, what do we have? If I directly put the 0 here, it will be 0 over 0. There is problem. Then I'm going to put a number that is too close to 0 on the left side. Going with negative 0.1 has no problem. So as test, we can say negative 0.1 inside absolute value over negative 0.1. This result will be positive. This one is negative. Positive divided by negative, the final answer will be negative 1. So the left limit for this function is negative 1. Now, for the same function, let's find the limit x approaching to 0 on the right side. Let's see that. Limit x approaching 0 on the right side for absolute value x over x. Then this time, again, if I put 0 directly, I will get 0 over 0. It's not clear. I'm going to choose a number that's too close to 0 on the right side. This number is 0.1. Now if I put 0.1 in place of x, I'll have something like absolute value 0.1 over 0.1. This is positive, the result is 1. Now look at the right limit. The right limit, or the limit on the right side, is equal to 1, while the limit on the left side is negative 1. Since the left limit and the right limit are not equal, then this limit does not exist. We showed that it does not exist. For any limit to show that it does not exist, we do left and right. And they should not be equal. Another piecewise function, given that the function f(x) is equal to x minus 1 when x is less than 0, x plus 1 when x is more than 0. All right. Show that limit x approaching 0 f(x) does not exist. Then we need to go with left and right. Limit x approaching 0 limit x approaching 0 on the left side. This little negative means left side. On the left side, I have x minus 1. Okay, if I put the 0 directly, it has no problem, it's not fraction. It will be 0 minus 1, that is minus 1. For the same function, limit x approaching 0 on the right side. On the right side of the function, we have this x plus 1, x plus 1. Then if I put 0 directly in place of x, it's not fraction, it has no problem, it will be 0 plus 1, which is 1. Now, this limit, and this one is negative 1. This limit does not exist because the right limit is not equal to the left limit. As you see. Another case of limit does not exist is when you have oscillating behavior. Oscillating behavior happens when you see sine or cosine, and what's happening inside the sine and cosine is infinity or negative infinity. What is infinity? In terms of limit, any number over 0 is infinity. And if the number is negative over 0, the result is negative infinity. So whatever case we have inside sine and cosine, this will cause an oscillating behavior. And oscillating behavior, the limit does not exist. The reason of that, because sine and cosine are wave functions between 1 and negative 1. Then oscillation is moving so fast. For every point here, if I take left and right, one of them is 1, one of them is negative 1. Then this is the reason of oscillating behavior. Every time, the limit does not exist because for every single point, if we do left and right, one of them is either 1 or either negative 1. They are not equal all the time. Then oscillating behavior, whenever you see something like this, the limit does not exist. And it happens if we don't see the graph, if there is infinity inside sine or cosine. Let's do this example. We can understand this better. The question says find the limit x approaching 0 for sine 1 over x. All right. If I directly put 0 here, it will not be 0 over 0. Then it is something. If I put 0 here, it will be sine 1 over 0. This is sine infinity. Sine infinity is oscillating behavior. The limit does not exist. Discuss the existence of the limit for limit x approaching 0 for cosine 1 over x. For the same reason, limit cosine x approaching 0 1 over x. This limit does not exist. The reason is it's oscillating behavior. It is a very fast wave function between negative 1 and 1. And the limit here does not exist. If we directly put 0, it will be cosine infinity. So this one does not exist. In exercises 1 to 6, use the graph of the function to find the limit if it exists. If the limit fails to exist, explain why. All right. We have some functions here. On these graphs, we are going to find these limits. Okay, number 1. Number 1. Limit x approaching 1 for x squared plus 2. Okay. X approaching 1. X approaching 1. 1 is here. Then, since the graph is one piece, at 1, result is between 4 and 2 is 3. Or we can directly put 1 here, limit x approaching 1 for x squared plus 2 is equal to 1 squared plus 2. This is direct substitution because the function is not fraction, 2 is 0 over 0. Then direct substitution 1 squared plus 2 is equal to 3. This limit exists because the graph is one piece, and the result of the limit is equal to 3. Number 2. Find limit x approaching 2 fx where fx is this. If we look at the graph, at 2, the value is 0. But we said for piecewise functions, when there is equal, not equal, we go with the not equal. Then we can put 2 here and get the result. 4 minus 2 is 2. Or we can look at the graph at 2 on the graph. Result is 2. Then this limit, x approaching 2 for fx is 2. Question 3. Question 3. This graph is broken. It's two pieces. One piece is here, one piece is here. Then the question asks about 5. 5 is where the graph is broken. This limit does not exist. Reason, left side of 5, result is negative 1. Right side of 5, result is positive 1. Then left limit is not equal to right limit, then this limit does not exist. Question 4. Limit x tends to 3, 1 over x minus 3. Again, the problem of this function is at 3. At 3, the graph is two pieces. Every time you see the graph is two pieces, we need to do left and right. If we approach 3 on the right side, the result is going to positive infinity. Goes up, doesn't stop anywhere, that's considered positive infinity. If we approach 3 on the left side, the graph is going down, and this one is considered negative infinity. Now the left limit and the right limit are not equal. This means the limit does not exist. Question 5. When you see this graph, it does not exist. Or if we put 0 here in place of x, cosine 1 over 0 is like cosine infinity. And whenever you see infinity inside sine or cosine, this is oscillating behavior. Limit does not exist. Question 6. Limit x approaching pi over 2 for tan x. Okay. Where is pi over 2? It's right here. Okay. On pi over 2, the graph is two pieces. One piece is right here, the other piece is going up. Then we do left and right. On the right side, if I approach pi over 2, I see the graph is going down and doesn't stop at any value. It's considered negative infinity. On the left side, if I approach pi over 2, the graph is going up and it doesn't stop at any value. It's considered positive infinity. Then, as x approaches to pi over 2, on the left side, result is positive infinity. On the right side, result is negative infinity. Right is not equal to left, then the limit does not exist. This question 7 is a good question. Use the graph in the figure on the right to estimate the limit when it exists. If the limit failed to exist, explain the reason. Okay. Part A. F of negative 2. F of negative 2, when x is negative 2, the graph at -2, the graph is going down. There is no graph right in front of -2. Then we can say f of -2 does not exist, or undefined on the graph. We cannot find it. Part B, limit x approaching -2. -2 is here. The graph is broken at -2. If we approach -2 on the right side, it's going up infinity. If we approach -2 on the left side, it's going down -infinity. Then left limit is not equal to right limit, then this limit does not exist. C, f of 0. F of 0, let's erase these. F of 0 is not here. This point is open, then it's not considered like f of 0. F of 0 is right here. So f of 0 is equal to 4. In front of 0, the graph is at 4. Then f of 0 is 4. Limit x approaching 0. X approaching 0, at 0, the graph is broken. These are two graphs. We need to do left and right. If we get closer to 0 on the right side, the graph is going to 4. So the right limit for 0 is 4. If we get closer to 0 on the left side, the graph is approaching a number here which is not 4. Then this limit does not exist. Left is not equal to right. This one, part E, f of 2. F of 2, there is no graph in front of 2. This one is open, then f of 2 does not exist. F of 2 does not exist. Limit x approaching 2. It's fine if a function at a value does not exist, but the limit exists. Look at this one, part F. Limit x approaching 2. X approaching 2, we are going to approach 2 on the left side and the right side. If I get closer to 2 on the right side, the graph is getting closer to this result. If I get closer to 2 on the left side, the graph is getting closer to the same value. Then this limit exists. And the result is this value. I don't know exactly what is this. This is 2. Halfway is 1. Then this is less than 1. It could be 0.5, 0.6. No number given. Then it's nearly 0.5. F of 4. F of 4. In front of 4, there is only one point. This is the graph of 4. The point is closed, so it's f of 4. F of 4 is this. This is 2. So f of 4 is equal to 2. Limit x approaching 4. Limit x approaching 4. If we get closer to 4 on the right side, the graph is going up, that's infinity. If we get closer to 4 on the left side, the graph is going up, which is also infinity. Then this limit is infinity, but infinity is not a real number. It's not like 5, it's not like 10. Then as limit, it has no certain value to approach. The limit is infinity, but if it's about exist or not exist, this one does not exist. If it's about exist, not exist, this one does not exist. But if it's about behavior of the function, as we get closer to 4, it will go to positive infinity. Okay? Infinity is not a number. It's not a real number. Then we cannot say this limit is equal to this number. It's infinity. It goes up forever. But when it's about exist, not exist, it does not exist.
گروپی لاس بۆ فۆتۆکۆپی و پەراوگا لە خزمەتی قوتابیانی خۆشەویستدایە. بۆ ئەوەی لە وەرزی نوێی خوێندن ماندوو نەبن، ئێمە هەموو پێداویستەکانی قوتابخانەمان بۆ بەردەست کردوون بە بەرزترین کواڵیتی و باشترین مەواد. لای ئێمە هەموو جۆرە مەلزەمەیەک بە کواڵیتێکی بەرز و جوانتری شێواز دەست دەکەوێت. هەروەها هەموو پێداویستەکانی قوتابخانە بە هەرزانترین نرخ دەست دەکەوێت. لە فۆتۆکۆپی لاس چاپکردنی کتێب و بزنس کارت و وەسڵ بە کەمترین ماوە و جوانترین شێوە. هەروەها چاپکردنی فلێکس و لەزگە و تابلۆ و چاپکردنی نووسین لەسەر کوپ و تیشێرت بە بەرزترین کواڵیتی. گەیاندنمان هەیە بۆ هەموو شار و شارۆچکەکانی کوردستان. بۆ دەستکەوتنی ئەم بەرهەمانە سەردانمان بکەن بەم ناونیشانە: هەولێر، دووسایدی بەحرکەی کۆن، بەرامبەر ئامادەی ژیاری نەحکومی. گروپی لاس بۆ فۆتۆکۆپی و پەراوگا.